Hello and welcome to this Further Maths past paper walkthrough. In this video, we are going to be looking at the Feather Mechanics paper for October-November 2024. That's 9231/31. Let's get right into it. Question number 1 says, a particle P is projected with speed u meters per second at an angle arctan2 above the horizontal from a point O on horizontal plane and moves freely under gravity. When P has traveled a distance 56 meters horizontally from O, it is at a vertical height h meters above the plane. When P has traveled a distance 84 meters horizontally from O, it is at a vertical height half h above the plane. Find in either order the value of u and the value of h. All right, so in this particular case, I'm going to illustrate the projection here. So we are going to be having horizontal ground and the particle projected from here, and it's projected, say, like this. Okay, let me try again. Okay, so projected like this at an angle which I want to call theta, where in this case theta, according to what's been given, is arctan of 2. The speed of projection is u meters per second. And we've also been told that it's been projected from O. Now, they say that when P has traveled a distance of 56 meters horizontally from O, it is at a vertical height h above the plane. So I'm going to take h to be the max here. So that's the point. So the coordinates would be 56 h. All right. And when it has traveled 86 meters horizontally from O, it is at a vertical height of half h. So let's say at this point, that's where we have the coordinates 84 horizontally and half h vertically. So that's basically what we have right here. So I'm going to make use of the equation of the trajectory. Now, the equation of trajectory, I'm going to write it as y is equal to x tan theta minus gx squared over 2u squared, and that's of cos squared theta. All right. Now, we're going to substitute the coordinates 56 and h. So when x is 56, y is h. So basically, we'll be having h being equal to 56 tan theta. Now, since theta is arctan 2, it means that tan theta is equal to 2. So we're going to be having 56 of 2 here, minus g, which is 10, of x squared, which is 56 squared, and that's divided by 2 of u squared, so u squared here, and that's of cos squared theta. Now we know that cos squared theta, actually 1 over cos squared theta is sec squared theta, and it's the same as 1 plus tan squared theta. So this is as good as 1, for 1 over cos squared theta here, I'll use 1 plus tan squared, which is 1 plus 2 squared. Okay, 1 plus tan squared theta. And since tan theta is 2, then it's 1 plus 2 squared, basically. So this is what we have. All right. So I'm going to do the calculations here just to simplify this thing. All right. So we will therefore be having h being equal to 56 times 2, which is 112. So we have 112 here minus, and then I'm just going to simplify this whole thing. Right, so I'll bring up my calculator and I'll type in all the constants. And I'm getting 78400. So we have 78400 all over u squared. So we're going to call this equation 1. Next, I'm going to substitute the other point, which is the point 84 and a half, all right? So 84 and a half of h, that is. And for that, I'll say this is my x value and this is my y value. So I'll be having half h is equal to x, which in this case is 84 of tan theta, which we said was 2, minus g, which is 10 times x squared, which is 84 squared, and that's over 2 of u squared. U is, okay, we don't know where, that's actually what we're looking for, right? And it's 1 plus 2 squared. Remember, we're using 1 plus tan squared theta here. So basically, we have half h being equal to, actually, what I'm going to do is just to simplify it all at once, I'll have h being equal to, so from here, I'm going to multiply all the terms by 2. Okay, so if we do so, on the left side, we are remaining with h. On the right side, 84 times 2 times 2 will give us 336, and that's minus. Now I'm going to simplify this whole thing here, all the constants. So I'll bring up my calculator again and type the whole thing in. And we're getting 352,800. All right. So we have that 352,800, and that's all over u squared. All right. So I'm going to call this equation 2, and I'm going to equate equation 1 to equation 2 since they're all h. So 112 minus 78400 over u squared being equal to 336 minus 352,800, and that's over u squared. All right, so we're going to rearrange, right? So rearranging this will give us minus 78400, all right, and that's going to be plus 352,800, and they all have a common denominator of u squared being equal to 336 minus 112. So I just rearranged, all right, and simplifying this, okay, just say minus 78400. We get 27440. So 27440 equals to, all right, I'm going to say what's 336 minus 112 is 224 actually. So we have 224 u squared. So u squared is 27740. Actually, this is 400 divided by 224. Okay. And we're going to do square root of this. All right. So I'll just say the square root of ants over 224, and we get 35. So U is coming out as 35 meters per second. So that's what they wanted us to find, right? They said we should find the value of U, and that's what U is. All right, so I'll say here, that's the answer. Okay. Now, the question also says we should find the value of H, all right? So I'm just going to create a bit of space because I wasn't using my space quite efficiently. So let's just say we have something like this. So to get the value of H, we can use even this equation here will be good. So basically, I'll say that H is equal to 336 minus 352,800 over U squared. So in this case, that's going to be over 35 squared. So therefore, H will come out as, and we will type that in. All right, so then this gives us 48. So 48 meters is the value of H. H is like the height, right? I'll take that to be like the maximum height. So that's the answer here. So we got our answers, U is 35 meters per second, and H is 48 meters. Okay, let's move on to the next question. On question 2, it says a particle P of mass m is attached to one end of a light inextensible string of length a. The other end of the string is attached to a fixed point O. The particle P is held at the point A with the string taut. It is given that OA makes an angle theta with the downward vertical through O, where tan theta is equal to 3/4. The particle P is projected perpendicular to OA in an upwards direction with speed root of 5 ag, and it starts to move along a circular path in a vertical plane. When P is at the point B, where angle AOB is a right angle, the tension in the string is T. Find T in terms of M and G. All right. So let's try to illustrate what we have been given here. Right, so I'm just going to have this to be a vertical, and I'm going to have this as being the horizontal. All right. So according to the question, we have a fixed point or, and we have a string that is inclined at an angle theta with the downward vertical. So this is theta, and there's a particle attached at the other end like this, and the mass of the particle is m. So we have here mg. All right. We also know that there's going to be tension in the string, so T here. Right. So that's the particle P held at the point A. So this has to be the point A where we are right here. All right. Then they also say here that tan theta is 3/4. So we'll need that information. Tan theta is equal to 3/4. And that actually means for us that if this is theta, then this has to be a 3, this has to be a 4, so this has to be a 5. So we can easily find sine theta and cosine theta as well, right? Then they say that the particle P is projected with a speed of root of 5 ag, and it starts to move along in a circular path in a vertical plane. And when P is at the point B, where angle AOB is a right angle, the tension in the string is T. All right. So we are going to have the particle at another point B, which is such that the angle here is going to be a right angle. And this is at a point B. So the particle is now here after it was projected. So this is the point B. All right. So angle AOB is a right angle. And they say that the tension in the string is T. All right. So we'll actually have the tension. Okay, I'm going to leave this. We'll give this another value. But the tension in the string, which should be going directed towards the center, will be T, okay, at B. So this is something that is key. And now we can solve the problem. I think we have illustrated enough. All right. Right, so the question says we should find T in terms of M and G. Right, so the key part is where they say that when P is at the point B, where angle AOB is a right angle, the tension in the string is T, and they want us to find T in terms of M and G. All right, so let us consider what's going on at B. And at B, if we consider Newton's second law, we can say here that the resultant force, which is due to the weight, that's mg, actually we'll need a component, the component of mg in the direction of t. So if I draw something like this to make a right angle with this direction, then we know that through geometry, this angle should be theta. So the resultant of the forces in the direction of t will be t plus mg sine of theta. So that's the resultant of that's actually the centripetal force okay, that is keeping B moving in circular motion. It's T plus the component of mg in the direction of T. That's mg sine theta. So this has to be equal to mass times acceleration, which will be mass times for acceleration. We'll use v squared. We don't know what the speed of the particle is when it is at B. So let's just call that v squared over r. The radius of the string, the length of the string is a. So it's going to be over a. So I'm going to call that equation 1. We're also going to consider the principle of conservation of energy. And to apply conservation of energy, here we applied Newton's second law. So for the conservation of energy, we're going to say the total energy at A is equal to the total energy at B. All right. Now for the total energy at A, okay, we're going to consider at A the speed. We've been told that the speed is root 5 ag. So the kinetic energy is half m of the square root of 5 ag squared. And that's going to be plus. Now, when it comes to the potential energy, we're going to take this level of O to be h equal to 0, which means we need this distance, this vertical distance. And seeing that the length is a and this angle is also theta, we can find that as a cos theta. So the height for GPE, we will use mg of negative a cosine of theta. And that's equal to the total energy at B, where the kinetic energy is half m v squared, because the speed is v, we don't know it yet, plus the vertical height h for that's going to be mg of, and we're going to find that this height, vertical height, to be, since the radius is a, and we know that this angle here is basically a 90 minus theta. So the vertical height is going to be a cos 90 minus theta, which is as good as a sine theta, basically. So that's what we are having right there. All right, so I'll simplify this. Simplifying this part, we will get 5 over 2 mga plus, actually this becomes minus mga cos theta, all right? But cosine of theta here is 4/5, right? So that's going to be minus 4/5 mga being equal to half mv squared and plus sine theta is 3/5, all right? So we have this information we need, all right? So basically, that's going to be plus 3/5 of mga. So that's what we're going to be working with, all right? So let me put this where we have enough space. So maybe down here. So we have two equations, actually. Let me place them down here. Okay, so we got this. I think it's all good. All right. Okay, let's carry on. So we are saying we can make half mv squared subject, so that we'll be having 5 over 2 mga minus 4 over 5 mga minus 3 over 5 mga. So on the right side, simplifying this is going to give us, we will say 5 over 2, which is 2.5, minus 4 over 5, which is 0.8. And that's going to be minus 3/5, which is 0.6. This is 11 over 10. So basically we have 11 over 10 mga being equal to half mv squared. So if we multiply both sides by 2, we'll be having mv squared being equal to 11 over 5 of mga. And that is after multiplying both sides by 2. So I'm going to say this is equation 2. And we can actually substitute equation 2 into equation 1. Okay, equation 2 into equation 1, where we're saying on equation 1 we had t is equal to mg sine theta. Okay, so t plus mg sine theta, which is like 3/5 of mg. Remember, sine theta is 3/5, is equal to mv squared. Okay, on top here we've got mv squared. So mv squared is 11 over 5 mga. So basically we have 11 over 5 mga over the a that's already there, this one. So they cancel out. So eventually we're just left with 11 over 5 of mg. So to get t, it will be 11 over 5 minus 3 over 5 all of mg. So we will get t coming out as 8 over 5 of mg. So the answer here is t is 8 over 5. Does that look like a proper 5? So 8 over 5 of mg. So that's how we find t in terms of mg for this particular question. Let's move on. Now we're on question number 3. Now in question 3, it says a particle P of mass m kilograms is attached to one end of a light elastic string of natural length 2 meters and modulus of elasticity 2 mg newtons. The other end of the string is attached to a fixed point O. The particle P hangs in equilibrium vertically below O. The particle P is pulled down vertically at distance d meters below its equilibrium position and released from rest. So on part A, given that the particle just reaches O in the subsequent motion, find the value of D. Okay, so let's illustrate what we are being told. So we have a point O from which the particle hangs. So let's say we have it like this. The natural length, we have been told that it's 2 meters. This is the fixed point O, and this is the particle. And this is at equilibrium position, all right? So when we are at equilibrium position, we have the tension and we have the weight of the particle, which is mg. So I'll say here at the equilibrium position, okay, because the question says that the particle hangs in equilibrium vertically below O, right? So very important. So at equilibrium, we're saying that T will be equal to mg. And yet we know that T is equal to lambda x over L, right? Where lambda is the natural length. So therefore, T should be equal to the lambda, which is the modulus of elasticity, that's 2 mg, times the extension x. So there's an extension here of x, and that's over L, which is the natural length, which is 2. All right. So basically, that's what we'll be having. All right. So the 2's cancel. And actually, for t, remember, we'd gotten here that t is mg at equilibrium position. So we can therefore say mg is equal to mgx, because that's what remains here, right? Which leads to us having x to be 1. If we divide both sides by mg, we get x being equal to 1. So we now know what the extension is at equilibrium position. So it is from there that the particle is pulled down vertically at distance d, right? So it is pulled down vertically. I'm going to remove this. Pulled down again vertically, another distance d. So eventually, okay, eventually it will be down here. All right. That's the same particle down here. All right. Another distance d. All right. And they say now given that the particle just reaches, or in the subsequent motion, find the value of d. Right, so it is being released from here, okay, which means that it is being released with a speed of 0 from rest, okay, and it just reaches O. So just reaches O means that when it reaches O, it will have a speed of 0, and it has been projected just enough to reach O. So the moment it reaches O, it will now be having a final speed of 0, right? So we're going to apply the principle of conservation of energy, where we're going to say that the total energy, when it was released, is equal to the total energy when it reaches O, when it just reaches O. So the total energy when this particle was released from this position, this level, the kinetic energy is 0. And we're also going to take this level to be h equals to 0. So it means, therefore, that the gravitational potential energy is also 0. So what remains is the extension, so the elastic potential energy, which we will calculate. Remember, elastic potential energy is lambda x squared over 2L. So lambda is 2 mg, okay? These are zeros. So 2 mg, x is the extension. The extension is x plus d. This is the extension, okay, from when it is released. So it's basically x plus d, but we got x to be 1 here, right? So it's 1 plus d squared, and that's over 2 times the natural length. So 2 times 2. This is equal to the kinetic energy at O. At O, the kinetic energy is 0, okay, because it just reaches O. So it will be having a final kinetic energy of 0. Then the gravitational potential energy we can calculate, which will be mg of this whole height, okay, and this height is 2 plus x plus d. Now x is 1, so it's 2 plus 1 plus d, which is 3 plus d. Then the elastic potential energy will be 0. All right, so this is all we'll be having. Right, so basically that's going to be, okay, we're going to cancel out. I'll cancel out this 2 and this 2 down. They divide into each other and go in once. I'll divide mg both sides. So that'll be like that. And I'm going to multiply both sides by 2. So this side by 2 and this side by 2. So the 2's cancel. So on the left side, we are left with 1 plus d squared. Actually, 1 plus d squared being equal to 2 of 3 plus d, which is 1 plus 2d plus d squared is equal to 6 plus 2d. So subtracting d from both sides and 1 from both sides, we'll be having d squared being equal to 5. So d comes out as the square root of 5. So d is the square root of 5. That's our answer to part A. Let's go to the next part. Part B says, hence, find the speed of P when it is 2 meters below O. The speed of P when it is 2 meters below O. All right, so let's use the conservation of energy. All right, the energy, total energy, when the particle was released is equal to the total energy of the particle at 2 meters below O. Now, when the particle was released, we say that we only have this, all right? We only have the elastic potential energy because GPE and KE are 0. So we will take this, all right? And that's the total energy when the particle was released. All right. And remember, we got D to be root 5. So on D, I'll put root 5 here. So we have root 5 all squared. This is equal to the total energy at 2 meters below ore. Now, at 2 meters below ore, it is at around this height. All right. At this level, when the particle is around about here. So when the particle is right here, we can calculate, first of all, the kinetic energy. Now, we do not know what the kinetic energy will be, so let's just say the speed was v. So the kinetic energy, sorry, is half mv squared. Then the gravitational potential energy, while at this level, the gravitational potential energy will be mg times the height, x plus d. So it's plus mg of x, which is 1, plus d. The elastic potential energy, if you look at this point, okay, if you look at this point where the particle is, we can see that this is where the particle will have an extension of 0 because it's actually 2 meters, where 2 meters is the natural length. So the extension is 0, which means elastic potential energy will be 0. So no elastic potential energy. So this is what we are going to be making use of for the calculations. Remember here, D is root 5. So I'll put a root 5 here. All right, so here I'm going to divide this 2 into this. So they go in ones. I'm going to multiply both sides by 2. So this side by 2, this by 2, and this by 2. So we will be having this 2 cancel, and these 2's also cancel. So on the left side, I'm left with mg, which is like 10m of 1 plus root 5 squared is equal to mv squared plus 2mg, which is like 20m of 1 plus root 5. Now, all the terms are divisible by m as well. So we will do that. And I will have the 10 multiply the expanded bracket. 1 plus root 5 all squared is like 1 plus 2 root 5 plus root 5 squared, which is 5. So 1 plus 5 is 6. So technically, we have 10 of 6 plus root 5, actually of 2 plus root 5, sorry, when we expand 1 plus root 5 squared, being equal to v squared plus 20 plus 20 root 5. So we have 60 plus 20 root 5 being equal to v squared plus 20 plus 20 root 5. I'll subtract 20 root 5 from both sides, and we will be having v squared equals to 60 minus 20, which is 40. So v is going to be the square root of 40, and the square root of 40 is like 2 square root 10, and that's in meters per second. So that is the speed we're looking for. They asked us to find the speed of P when it is 2 meters below O. So we find that to be 2 square root 10 meters per second. Let's move on to the next question. Now we're on number 4. On number 4, the question says, an object is formed by removing a cylinder of radius 2/3 a and height kh from a uniform solid cylinder of radius a and height h. The vertical axis of symmetry of the two cylinders coincide. The upper faces of the two cylinders are in the same plane as each other. The points A and B are the opposite ends of a diameter of the upper face of the object. So in part A, find in terms of fraction K the distance of the center of mass of the object from A, B. All right. So in this particular case, okay, in this particular situation, we are going to use the fact that mass is proportional to volume. All right. And we're going to use the negative mass method. So we are going to have M1. M1 is the mass of the solid cylinder. That's the mass of uniform solid cylinder. So basically, the M1 will be the volume of the whole cylinder. So volume of cylinder is pi times radius squared. The radius is A, so it's going to be pi A squared times H. The height of the bigger cylinder is H. So this, right? So that's what we have as M1. Now we're also going to have M2. M2 is the mass of the removed cylinder. So the removed smaller cylinder here has a radius of 2/3 A. So for its volume, it will be pi times 2/3 A squared, and its height is KH. So it's times the height, KH. So this can be simplified to 4/9 of pi A squared KH. Now, big M is the combined mass. It is going to be M1 minus the removed mass, which is M2. So it's pi A squared H minus 4/9 pi A squared KH. So that's basically what M is. Now, this can be expressed as, if we are going to factorize, we can factor out pi A squared H over 9. And if we do, we'll be having 9 minus, factor out, 4K. So that is basically M simplified. So we're going to use the fact that M since the center of mass is on a vertical height, I'll just use Y. So Y bar is equal to the sum of MI, YI. So basically that's going to be pi A squared H over 9 of 9 minus 4K of Y bar is equal to the sum of MIXI, starting with M1. M1 is pi A squared H times the distance of its center of mass from AB. Remember, it's relative to AB. All right. So this is AB. And the center of mass of the bigger cylinder is at a right at the geometrical center. That's where G is, G1. So this distance from AB, perpendicular distance, is half of H. It's basically half H. So that's what we're going to use for the moment. So times half H. It's going to be minus, okay, because we're talking about the removed mass. So that's minus M2, which is 4/9 pi A squared KH times the distance to the center of mass. Right, so we're saying from AB, which is technically, right, just the center of mass of the removed cylinder will be halfway through, which is half of KH, right? So it's times half KH. All right, so that's what we're going to be working with, all right? So let's just save on space because it seems space is running out and we still got a few more things to talk about. I think we're good. Let me just move this up a little. All right, so from here, we are going to be having the pi A squared H over 9 of 9 minus 4K of Y bar being equal to. Now, from what we have here, all right, because what we have right here simplified is actually half pi A squared H squared minus here. That's going to be 2/9 pi A squared K squared h squared. So basically that's the same as pi a squared h over 9 of 9 minus 4k of y bar is equal to, and I'll factor out pi a squared h over 9 here, which will give us 9 over 2 of h minus, if we divide that into here, 2k squared h. So I'm going to divide this 2 from both sides and make y bar the subject, okay, on the left side. So we are left with y bar. So on the right side, we will be having, on this remaining thing, I'll factor out a half of h. So that we'll be having 9 minus 4k squared in here. And at the bottom, since I'm dividing by 9 minus 4k, it's 9 minus 4k. So this is the same as saying y bar is equal to h of 9 minus 4k squared over 2 of 9 minus 4k. This is the answer, and that's how we find it. All right, the distance of the center of mass of the object from AB. Okay, that's y bar, and that's how we do it. Let's move on to the next part, which says when the object is suspended from A, the angle between AB and the vertical is theta, where tan theta is equal to 3 over 2. So on B, given that h is equal to 8 over 3 of A, find the possible values of K. All right. All right, so the object is being suspended at A. So this is A, and A is like this point here. Now, when it is suspended at A, it means the center of mass of the whole object, wherever it is. Let's say it's here, okay? The center of mass of the whole object should be vertically below A. Okay, so basically what we're saying is, if that is so, then the center of mass should be vertically below. It has to be vertically below. So let's say this is G. So it has to be vertically below A. Now we also have the side AB. All right. So AB is maybe like this. Right. And this is like, if we draw a line here, we should touch the midpoint perpendicularly. So let me do that properly. So this is basically the situation we got. So AB and G, which is the center of mass of the object, vertically below A. All right, so that is geometrically what we have. Now, this is perpendicular. So we have a right angle here, and halfway through AB is the radius, which we said was A. This is angle theta. All right. And the distance from AB to G is y bar. All right. So this is actually what we have. So if we're going to make use of the diagram, what we're saying here is A is here, the center of mass of the object is down here. Sorry. Okay, so the center of mass is down here, and AB goes like this, and this is the distance. This is y bar, a right angle, and this is the angle theta. So basically, that's the situation, and this is A. All right. So we are going to make use of this information to find what needs to be found, to find, they say, the possible values of K. Right, so we are going to say here that tan of theta is equal to opposite over adjacent. And they told us that tan theta is 3 over 2. So 3 over 2 is equal to y bar. We got y bar to be this. So we're going to make use of it down here. All right, so this is what we have. And it's actually over A. So I'll put an A here at the bottom. All right. Now, we have been told that H is 8 over 3 of A. So it's as good as we have 3 over 2 being equal to 9 minus 4k squared over 2 bracket 9 minus 4k. And for H, this H, I'm gonna use 8 over 3 of A, and that's over A. So the A's are going to cancel, all right? So what we have is 3 over 2 is equal to 8 of 9 minus 4k squared, and that's over 3 of 2, which is 6 of 9 minus 4k. So we will cross multiply, and if we do, we'll therefore be having 18 of 9 minus 4k being equal to 16 of 9 minus 4k squared. Now, all of these are divisible by 2. So we've got 9 of 9 minus 4k being equal to 8 of 9 minus 4k squared. I'm actually going to expand this. So 9 minus 4k all squared. Actually, this is 9 minus 4k. The squared is inside. All right, so I think 9 minus 4k squared should be all right. Expanding the brackets, that's going to be 81 minus 36k is equal to 72 minus 32k squared. So rearranging, we'll be having 32k squared minus, actually, yes, minus 36k, and 81 minus 72 is 9. So plus 9 equal to 0. And we're just going to solve for k here. So solving for k, we'll be having mod 5, 3. So 32, negative 36, and 9. And the values of k are 3/4. And the other value is 3/8. So these are the two possible values of k. The question had said we should find the possible values of k. And that's what we got right on here. And that's how we do it. Let's move on to the next question. Question number 5. So on question 5, it says a particle P of mass 2 kilograms moving on a horizontal straight line has displacement x meters from a fixed point O on the line and velocity v meters per second at time t seconds. The only horizontal force acting on P is a variable force F newtons, which can be expressed as a function of t. It is given that v over x is equal to 3 minus t over 1 plus t. And when t is 0, x is equal to 5. So on part A, find an expression for x in terms of t. All right, so here we've got v over x being equal to 3 minus t over 1 plus t. Now, this is the same as 1 over x of v, but we know that v is dx by dt, so that's equal to 3 minus t over 1 plus t. All right, so we can separate the variables, so that we'll be having 1 over x of dx is equal to 3 minus t over 1 plus t of dt, and we introduce the integral right here. Now, on the right-hand side, you can see that we actually have an improper fraction. All right, so we can actually divide 1 plus t, which is like t plus 1, okay, into 3 minus t, and it goes in minus 1 times, so that's minus 1 minus t, essentially, and 3 minus the remainder is 4 here. So we can basically say that the integral of 1 over x with respect to x is equal to the integral of minus 1 plus the remainder 4 over 1 plus t, and that's with respect to t. So we can now integrate. The left side gives us ln x, and on the right side we get minus t, and integrating this part should give us 4 ln of 1 plus t, and that's plus c. Now we have been told here that when t is 0, x is 5. So when t is 0, x is equal to 5. So substituting that will give us ln of 5. So ln 5 is equal to, this part becomes 0, and here becomes 0. So 4 ln 1 is 0. So we're just left with c. So therefore, we can say that ln x is equal to minus t plus, this part I'll write it as ln of 1 plus t to the power of 4, and that's plus c, which is plus ln 5 that we got. So that's now our particular solution. Now, the question says that we should express x in terms of t. So I'm going to erase both sides with the base e. That means that on the left side, we'll be having e to the ln x, and on the right side, it's e to the negative t of e to the ln of 1 plus t to the 4 of e to the ln 5. So e to the ln x here gives us x, and on the right side, we have e to the negative t, and this part gives us 1 plus t to the power of 4, and this part gives us 5 basically. All right, so we have right here, if I rearrange it, x being equal to 5e to the negative, okay, let me write it this way. It's actually 5 of 1 plus t to the power of 4 of e to the negative t. So that is the answer we get right on part A. Let's move on to part B, and it says, find the magnitude of f when t is equal to 3. Find the magnitude of f when t is equal to 3. Now, we know that f is equal to ma, and we know that a is, well, dv by dt, okay, basically. Now, in our particular case, we have this original equation, all right? Let me just copy it from here. So this is the original equation, and I'm going to place it here where we can see it. Okay, here it is. So this here is the original equation. Okay, let me just put it in here. I think it's fine. So we need to find A first, right? And A, like I said, is dV by dt. And V, looking at the original equation, should be 3 minus t over 1 plus t of x if we multiply both sides by x in this equation. So we are therefore saying that A is equal to, and now we can differentiate V with respect to t. All right. But before we do that, this is like 3 minus t over 1 plus t of. Now remember x, we got it to be this. So we're gonna just make use of what we got x to be. All right. For the sake of homogeneity in the variables. So this is actually what we're working with, right? And this is actually 3 minus t. We have a 5 here, right? So we have 1 plus t to the power 3 of e to the negative t. Okay, so that's what we are differentiating, because this is actually v. So dv by dt will give us, now we are differentiating, I'll have a product of this and this. So that's e to the negative t times the derivative with respect to t of 5 of 3 minus t of 1 plus t to the power 3. And that's plus 5 of 3 minus t of 1 plus t to the power 3 of the derivative with respect to t of e to the negative t. So that's e to the negative t. And that's of the derivative of this. So I'm going to treat this as a product again. So that's going to be 1 plus t to the power 3 of the derivative with respect to t of 5 of 3 minus t plus 5 of 3 minus t times the derivative with respect to t of 1 plus t cubed. And that's going to be plus this, right, which is 5. Actually, let's just perform the derivative, because we know that differentiating this gives us minus of e to the negative t, e negative t. So that's going to be minus 5 of 3 minus t of 1 plus t cubed of e to the negative t, basically. Right, so let's continue simplifying. Here we'll be having, all right, e to the negative t of, and the derivative on this part comes out as minus 5. So we have minus of 5 of 1 plus t, and that's 1 plus t cubed. The cube is outside the bracket. This cube is outside the bracket, so let's write that down properly. Okay, so t cubed, like this. And that's going to be plus. And here we've got 5 of 3 minus t. And on this part, differentiating, we should get 3 of 1 plus t squared. And that's minus 5 of 3 minus t of 1 plus t cubed of e to the negative t. So we have e to the negative t of minus 5 of 1 plus t cubed, and that's plus 15 of 3 minus t of 1 plus t squared, and that's minus 5 of 3 minus t of 1 plus t cubed of e to the negative t. All right, so here I'm going to factor out minus of e to the negative t, and I'm also going to factor out 1 plus t squared. And actually, I'll have a 5 as well. So let me factor out minus 5 rather, because that's common. So minus 5e to the negative t of 1 plus t or squared. So if we factor that out, it means that we'll be having on this part, we factor out minus 5 and that and that and that, we get just 1 plus t. And on this part, we will get 5 into 15, that's 3 of 3 minus t, right? And on this part, all right, here I'm going to change the sign. It has to be negative, hey? So negative here. So I think we're good so far. Then we're going to go to this part, so it becomes a plus, and we have 3 minus t and 1 plus t remaining. So that's basically what we have. So that's going to be minus 5 of e to the negative t of 1 plus t squared, and that's off. And inside the bracket, that's 1 plus t minus 9 plus 3t. And expanding brackets here, that's going to be plus 3, and then minus t plus 3t, that's going to be plus 2t minus t squared. All right, so minus t plus 3t. Okay, I think it's all right. So we basically have minus 5e to the negative t of 1 plus t squared. And here we've got minus t squared. And for the terms in t, we have t, 3t, and 2t. And that gives us 6t. So we have 6t here. And for the other terms, we have 1 minus 9, which is minus 8, and plus 3, that will give us minus 5, basically. So that's what we'll be having. All right, so that's going to be factoring out a minus. We now have 5e to the negative t of 1 plus t squared of t squared minus 6t plus 5, which is 5e to the negative t of 1 plus t squared, and that's off. Here we've got t and t, 5 and 1, then minus and minus. So this is what we'll be having. So that's what we get right here. That's A. So remember, F is equal to MA. So since F is equal to MA, we'll be saying that here we'll be having 5 of M. The mass here is actually 2 kilograms. And remember, T is 3. All right. So let's work with that. So that's going to be 2 and times the acceleration. So 2 times 5e to the negative 3. All right. And that's off. 1 plus 2, that's 1 plus 3 here, which is 4 squared. So that's 16. And here, 3 minus 5 is minus 2. And 3 minus 1, that's 2. So that's of minus 4, basically. And what we'll be having now is our answer being 2 times 5, that's 10. 10 times 16 times 4, so that's negative 640 e to the negative 3, which will take the magnitude off, which means that F will just be 640 e to the negative 3 newtons. So that's the answer here. So that's how we do it for this particular question. Let's move on to the next one. Lesson number 6. It says, a particle P of mass 0.05 kilograms is attached to one end of a light inextensible string of length 1 meter. The other end of the string is attached to a fixed point or. A particle Q of mass 0.04 kilograms is attached to one end of a second light inextensible string. The other end of the string is attached to P. The particle P moves in a horizontal circle of radius 0.8 meters with angular speed omega radians per second. The particle Q moves in a horizontal circle of radius 1.4 meters, also with angular speed omega radians per second. The centers of the circle are vertically below O, and OPQ are always in the same vertical plane. The strings OP and PQ remain at right angles, alpha and beta, respectively, to the vertical, as seen on the diagram. So on part A, find the tension in the string OP. All right. So we want to find the tension in the string OP. Now, we know that the particle P has got a weight, okay? They both have weights, okay? The weights are, according to the question, 0.05 G it has to be, and 0.04 G right here. We also know that we have tension in the string. Here, I want to call that T1. And there's also tension in string PQ. So that's T2 here. All right. So this is actually what we have. All right. So to help us find the tension in the string OP, we are going to make use of, actually, we're going to resolve the forces because vertical wise, we know that we are experiencing equilibrium. So technically, the vertical forces are going to be T1 cos alpha, which is the component of T1 going up, all right? And that's going to be equal to the downward forces acting at P. Okay, so we're talking about forces acting on P. Downwards on P, we have 0.05 G, and we also have the component of T2, so plus T2 cos beta. That's the downward component of T2 acting on P. Let's also consider equilibrium. vertical wise. Okay. For Q, the forces acting on Q upwards is T2 cos beta being equal to the downward force 0.04 G. All right. So these two equations, I'm gonna solve them simultaneously. So I'm just going to substitute what's in equation 2 into what's in equation 1. So that when we write equation 1, it's T1 cos alpha is equal to 0.05 G plus T2 cos beta, which is 0.04 G. So T1 cos alpha is 0.09 G, and T1 is therefore 0.09 G, which is 0.9 divided by cosine of theta. So cosine of theta. Now cosine of theta can be found because if you look at the right angle triangle here, okay, and by right angle triangle, I mean this right angle triangle. All right, you can see here that we've got a 0.8 and a 1. Basically, that's 4/5. We can write that ratio as 4 and 5, which means this is a 3. And this actually, this angle is alpha. So cosine of alpha is 3/5 or 0.6. So it's as good as 0.9 over 0.6, which is 3 over 2, which is 1.5 newtons. So that is how we find that. Let's go on to part B. Find the value of omega. So now we're going to consider Newton's second law. Basically, we're going to resolve horizontal wise. So for part A, we considered equilibrium and we resolved vertical wise. But right now, since we are now talking of omega, which is the angular speed, we have to resolve towards the center of each circle. So let's start with particle P. And for particle P, the resultant force directed towards the center is the component of T1 towards the center. And that component is T1 sine alpha. All right, so I'll have that. So we have T1 sine alpha. And since T2 is pulling on P, all right, we can consider the component of T2, which is going in this direction, basically. All right, or rather, for T2, let's have its components like this. The components of T2 can go down, then like this. So the component of T2, in this case, we're considering T2 pulling on P. So we consider intention to be going in this direction. So the component going opposite, that's component of T2, is T2 sine beta. So basically, it's not here. Remember, we're talking about P, and T2 is pulling on P. So the component of T2 pulling on P is T2 sine beta, basically, if you understand. So T2 sine beta. So that's the resultant force. T2 sine beta. It has to be equal to mass times acceleration, which is m omega squared r. That's the acceleration. That's the mass times acceleration. So it's m times omega squared times, do we know what the mass is? I think we do know the mass of P to be 0.05 kilograms. So that's 0.05 times omega squared times the radius. The radius is 0.8. So it's going to be times 0.8. So basically we have T1 sine alpha minus T2 sine beta is equal to, and we multiply the two, we get 0.04 omega squared. That's equation 1. Let's look at Q. Resolving towards the center for particle Q. Let me remove all the other things. Okay, there's tension, T2. All right. So we have T2 here. So the component of T2 is directed towards the center. The center is here. All right. So T2 sine beta. That's the first one. So T2 sine beta. Any other force horizontally pulling on Q? There's no other. So this has to be equal to mass times acceleration. So it's equal to m, which is 0.04 omega squared. R, the radius of the bigger circle, is 1.4. So we have times 1.4. So this is T2 sine beta being equal to this, which is 0.056 omega squared. All right. So this is what we have in, and I'll call that equation 2 for this part. So if we say 1 plus 2, we have t sine alpha, and this minus this plus this gives us 0. Then we will add this, and they will give us 0.096 omega squared. Sine alpha. Okay, we actually have these values, right? On A, we got T to be 1.5 newtons, and we know that sine alpha, okay, sine alpha here is actually sine alpha is 4/5 or 0.8. So equals to 0.8. So therefore, omega squared will be T sine alpha, which is 1.5 times 0.8. Okay, let me use the proper pen. Okay, so T sine, sorry, omega squared will be 1.5 times 0.8 divided by 0.096, which will give us, okay, if we type that in, that's 12.5. So omega will be the square root of 12.5. So omega will be equal to 5 root 2 over 2. 5 root 2 over 2. And that's radians per second. And that's the answer. So that's how we do it for part B. Part C says we should find the value of beta. All right, so to find the value of beta is no longer a difficult thing. We can make use of these equations. We earlier got T cos beta to be 0.04 G. So this was T cos beta. And we actually got T sine beta here, T2 sine beta. So these are the two. All right. And this was omega squared, right? Omega squared um, is 12.5 according to what we have right above. So this is times 12.5. So basically, if we divide these two equations, we get tan beta is equal to 0.056 times 12.5 divided by 0.04 G, which is 0.4. Okay, let's type that in. 0.056 times 12.5 over 0.4, which is 7 over 4. So basically, tan beta is equal to 7 over 4. So beta is equal to arctan of 7 over 4. And arctan of 7 over 4 is 60.3 degrees. Therefore, beta is 60.3 degrees. So that's the answer here. And that's how we do it. Let's move on to the last question. Question number 7, and it says, a particle P is projected with a speed u at an angle arctan of 4/3 above the horizontal from a point O on a horizontal plane and moves freely under gravity. When P is moving horizontally, it strikes a smooth inclined plane at the point A. This plane is inclined to the horizontal at an angle alpha, and the line of greatest slope through A lies in the vertical plane through O and A. As a result of the impact, P moves vertically upwards. The coefficient of restitution between P and the inclined plane is E. So in part A, show that E of tan squared alpha is equal to 1. All right, so let us look at the situation, all right? We have a horizontal plane, we have a particle projected with a speed u meters per second, and it travels. But when it is moving horizontally, and that means that when it reaches its maximum height, they say that it strikes a smooth inclined plane. So there's a smooth inclined plane here struck by, okay, so let's say this is, the plane is inclined, they say, at an angle alpha. So there we have the impact going on, all right? And this was projected with an angle theta, where I'm saying theta is arctan of 4/3. Okay, so this is what we have essentially. So if we look at the collision, all right, we have the inclined plane, all right, and a particle coming in this direction. It strikes the plane, and then it is projected perpendicularly upwards because they say as a result of the impact, P moves vertically upwards. All right, so like this, that's the type of situation we have. All right, this angle is alpha, so this should also be alpha by geometry. And this is 90 minus alpha then, because this is a right angle. Now the speed of impact, the speed with which the particle approaches the plane or strikes the plane, is the horizontal component of speed of the particle, ux, which is u cos theta. All right. Remember, if this is theta and tan theta is 4/3, then cos theta is 3/5. So it's 3/5 of u. So basically that's what we have. So the speed is 3/5 of u, right? So that is something very important. That's the speed with which the particle, that's the horizontal speed, basically, with which it strikes the plane. So we're going to say before collision and after collision. This is how I prefer to do it. So we will look at the parallel components. So before collision, the component of the 3/5 u force, which is parallel to the plane, is 3/5 u cos alpha. And the component of the force, because here we don't know, let's just say this is the speed v with which it leaves the plane. So we will call that v cos of 90 minus alpha. Now v cos, okay, with parallel components, we know that they do not change. So these two are equal, okay? The parallel component before collision is equal to the parallel component after collision. So I'll just say this is equal to 3/5 u cosine of alpha, and I'll call that equation 1. And then for the components that are parallel to the plane, that is the plane of collision, the components perpendicular, okay, for the 3/5 u force, the perpendicular component is 3/5 u sine 3/5 u sine alpha, right? So we have 3/5 u sine alpha, and after collision, it will be v sine of 90 minus alpha. Now, this components, because this one is going towards this one perpendicular component is leaving. So we take this as approach and separation, basically. So they obey Newton's law of restitution. So the relative speed of separation, this should be equal to E times the relative speed of approach, which is the approaching component. So it's E of 3/5 u sine alpha. Now we know that if we are going to do things properly, with the first equation, cosine of 90 minus alpha is sine alpha. So it's as good as V sine alpha is equal to 3/5 u cosine alpha. That's, let's just have that as equation 1. And V sine alpha, V sine means sine of 90 minus alpha is cosine alpha. So it's like we have V cosine of alpha being equal to, here is 3/5 EU sine alpha. And that's the equation 2. Oh dear. That's equation 2. So if we say equation 1 divided by equation 2, we will be having on the left side V sine alpha over V cosine of alpha being equal to 3/5 u cosine alpha over 3/5 EU sine alpha. So on the left side, that's tan alpha. And on the right side, the 3/5 u cancel out. So we'll be having 1 over E tan alpha remaining. And if we multiply both sides by E tan alpha, we will be having E tan squared alpha being equal to 1. That's what they want us to prove here. Therefore, shown. Let's go to part B, where it says, in the subsequent motion, the greatest height reached by P above A is 3/16 of the vertical height of A above the horizontal plane. So on B, find the value of E. All right. So to answer this question, we are going to start by calculating the vertical height of A above the horizontal plane. Okay. According to the question, the point A is the point at which the ball struck the plane, the inclined plane. So basically, we're looking for the maximum height, right? So that's basically H max, which we calculate as U sine theta squared over 2G. So in this particular case, we are going to say for U sine alpha, U sine theta rather, sine theta is 4/5. So it's 4/5 of U squared divided by 2G. All right. And this will give us 8 U squared over 25G. All right. 8 U squared over 25G if we simplify it. So that's the greatest height. That's the maximum height right there. And then from here, we are going to consider these two equations. All right. Equation 1 and equation 2. So let's have that. So I'm going to have the two equations. So equation 1 here. And I'm going to remove this. And we'll have equation 2 here. All right. And I'm going to say equation 1 squared plus equation 2 squared And if we do so, we'll be having on the left side for these two, it's v squared of sine squared alpha plus cos squared alpha being equal to, on the right side, is 3/5 u o squared of cos squared alpha plus e squared sine squared alpha, basically. So v squared is equal to 9/25 u squared, and that's of cos squared alpha plus e squared sine squared alpha. All right. So with what we have right here, we're going to say, since the question says in the subsequent motion, the greatest height by P above A. So we're talking about the greatest height, okay, from when the particle strikes the inclined plane and it goes up. Its greatest height above A is actually such that the speed with which it left is v, from which we are saying we have v squared, and the final speed is 0 because that's how it's going to reach the final speed. So 0 meters per second, and acceleration is negative g. So we're going to consider the equation of motion. V squared is equal to u squared plus 2as. So basically, that's 0 squared is equal to u squared, which is this speed, which is denoted by v squared actually. So basically it's 9/25 u squared of cos squared alpha plus e squared sine squared alpha. And that's plus 2as, which is minus 2gs. So that's the height we're looking for, with which it it goes to its maximum. So with this, we are saying 9/25 u squared of cos squared alpha plus e squared sine squared alpha is equal to 2gs. Okay. Okay, so 2gs is 2 times 10 times s. Now, s is the height, okay, according to the question, it is the height, the greatest height reached by P above A, which is 3/16 of the vertical height of A above the horizontal plane. So basically, S is 3/16 of the maximum height, which is 8u squared over 25g. So 8u squared over 25g. So this is the thing that we want to solve and see what it will give us. Right, so basically I'm gonna simplify the right-hand side. All right, and at the same time, before I do, I'll multiply both sides by 25 over u squared. Okay, and this side by 25 over u squared. So I know that the u squareds cancel out, and the 25s as well. The 25 and 25, u squared and u squared will cancel out. Okay, so on the left, I'm having 9 of cos squared alpha plus e squared sine squared alpha. And on the right side, I'm just going to calculate this thing that we got. So we have 2 times 10 times 3/16, and that's times 8. Okay, so we basically have 30 here, and there's over g, right? 30/10, so that's just 3, right? So basically, cos squared alpha plus e squared sine squared alpha is equal to 3/9, which is a third. Right, so there's a relationship we got on part A. This relationship, that's E of tan squared alpha is equal to 1. So I'll say here, E tan squared alpha equals to 1. Let's consider a right angle triangle. And here, if we have this, it means that tan squared alpha is equal to 1 over E, and tan alpha is 1 over root E. So if this is alpha, then the opposite will be a 1, and adjacent will be a root E. So the hypotenuse will be the square root of 1 plus root E squared, which is E. So that's the hypotenuse. So we can say for cos squared alpha, okay, it is adjacent of hypotenuse. So this over this, O squared. So it's E over 1 plus E. And that's plus E squared of sine squared alpha. Sine squared is opposite over hypotenuse. So it's 1 squared over 1 plus E basically. And it's equal to a third. Okay, so that's what we will be having. So what we have is like the bottom here is 1 plus E, and on top we have E plus E squared is equal to a third. So here I'm going to cross multiply, right? And we'll be having 3E plus 3E squared is equal to 1 plus E, which is 3E squared plus 2E minus 1 if we rearrange the terms. So we can actually have 3E and E here, 1 and 1, and plus here and minus, all right, such that the values of E come out as a third or minus 1, but we will rather have the positive one, E being equal to a third. So this here is the answer, and that's how we do it. E is equal to a third.